All right, so we're gonna look at these trig identities, which half of them you already know, and we will see how we use them to try to simplify and kind of manipulate these expressions we're gonna be working with. All right, so the first set is the reciprocal identities. You guys already know these reciprocal functions, don't you? What sign's reciprocal?
O over H,
In
right?
terms of the trig functions,
Oh. What is that?
Y over 1.
Oh.
right? But what in terms of like a trig function,
What?
not a coordinate value, in terms of a trig function, sign's reciprocal is cosecant, right?
Oh, you mean
Oh.
oh.
That's what I mean by
That's not what
But
I
reciprocal.
thought
it
you were
says it on the
asking.
board, so we were just like, we don't need a. Yeah. We were confused.
I might have asked the question poorly, but yeah, reciprocal in terms of trig function. So sine of theta is equal to 1 over the reciprocal cosecant of theta. That should be CSC. All right, we could go the other way. Sine is yeah, let me rewrite that. That should be CSC. All right, and then sine is the reciprocal of cosecant. So I can rewrite cosecant theta as 1 over sine. What's cosine's reciprocal? Secant. So I can write this as 1 over secant. I can rewrite secant as 1 over cosine. And then tangent and cotangent are reciprocals. So I can do the same with them. Tangent can be written as 1 over cotangent. Cotangent 1 over tangent. All right, so these will be interchangeable. If you see like either form of this, you can write it into the other form. So if I saw something and it was 1 over sine theta, I can rewrite it as cosecant of that angle. Right, we already knew these though, didn't we? Okay, and we briefly talked about the even and odd functions. Briefly, I don't think we looked at it or anything, but I did tell you that like, well, what's cosine of 45 degrees? Or better yet, not even 45, because we already did this. What was cosine of 30? Of 60, I'm sorry.
Of 6.
Of 60. 1/2, right? I was trying to pick one we already did. 1/2. What is cosine of negative 60?
Negative 1/2. Oh, no. Oh, no. Wait, it is?
Negative 60 is right here, right?
It is. It's 1/2.
It's still 1/2,
Yeah.
because the x is
X
positive. So we say all that to say it doesn't matter if the angle's negative or not, the value is going to come out to be the same. So even if I had negative 60 as an angle for cosine, if I know what cosine of just 60 is, it's going to be the same value. So because of that, cosine and secant are even functions because cosine of a negative angle is the same as cosine of that same positive angle. So you can just do away with the negative sign. The same is true for secant. Doesn't matter if the angle's negative, the answer, the exact value is going to turn out to be the same. So whatever you see these, you can rewrite it as just cosine or as just secant. Now the other 4 functions are odd functions, but we can rewrite those too. If I have sine of a negative angle, I can just rewrite it as negative sine of the positive version of that angle. All right, so basically you can take the negative sign and just make the whole function negative instead of looking at the negative angle. That's for all of the other functions. So cosecant, I can just do negative cosecant theta.
Wait, I thought we were supposed to write cosecant with that weird circle.
Right here?
Wait. No, I did. Just good.
Okay. Did I not do that?
Oh, no. It could be
All right, so these first 2 we call even. The other ones are odd, but that just means you can just make the whole thing negative, not the angle. Let the angle be positive, just make the outcome negative. Then you get your value. So whenever you have negative angles we're working with, we'll see in a second, you can rewrite it in one of these different forms for each one.
Wait,
All right.
so if it's odd, we just make the whole thing negative, and if it's even, we just leave it as positive.
Yeah, you just do
Okay.
away with the negative because it won't matter. All right, just a couple more. Let's do quoting identities. So quoting is like dividing two things. So tangent. Tell me what you know about tangent. What's the ratio for tangent?
Y over x.
Y over x. I like that. So if we say tangent is y over x, which function is associated with y?
Cosine.
Sine.
So it's sine over cosine.
It's sine over cosine.
And cotangent is cosine over sine.
Cotangent is flipped. Okay, so for the quoting identity, whenever you have tangent of an angle, you can rewrite it as sine of that angle divided by cosine. Or if you start off with sine over cosine, you can change it to tangent. Works either way. Cotangent is the reciprocal, so like London said, we just flip these two. If you have cotangent of an angle, it'll be cosine over sine. All right. And then we got the Pythagorean identities. Pythagorean's theorem. That's what we hear all the time, right?
We do?
That's where
Oh, yeah, we do. Sorry.
that's where these come from. Okay? So just very briefly, I'll bear you the lecture where all of these come from, but we basically take Pythagorean's theorem, a squared plus b squared equals c squared. We change it into trig on the unit circle, x squared plus y squared equals a radius of 1. And then we put in trig functions to replace it, and that's where these identities come from. So we said x is associated with what? Cosine? So I could write this as cosine squared of some angle plus what's y?
Sine.
Sine squared of the same angle. This will come out to equal 1 on the unit circle. So this is where these Pythagorean identities come from. Just Pythagorean's theorem. Right? You get these other identities, and you don't have to write this, but if we divided all of these terms by, say we divided by cosine. And you don't have to write this. You get these other identities. So this would simplify to 1. Sine squared over cosine squared is which one of these? Tangent. So I could rewrite this second one as tangent. And then cosine's reciprocal is what? Secant. So if I have 1 over cosine, I can rewrite it as just secant.
Is that what we're doing today?
So this isn't all we're doing. So this is like where these come from. So for this one, I could 1 plus tangent squared theta would be secant squared theta. And then on this last one, if I divided everything by sine, what I would get is cosecant. Okay, so you don't have to remember all this. You just need to know these ones. Well, this is where it comes from. Pythagorean's identity, we change it into trig. All right, so we're going to look at these expressions, and we're going to use these identities. Nothing's wrong with your eyes, it was this. We're going to use these identities to simplify these expressions. All right, so like I say, you know half of these. In the past, like if let's say it was a test, the first part of your test might be fill in the blank. So everything that you see here that we wrote, you be given a piece of paper and you need to just fill all that out. That could be like part 1 of your test. You turn that in. I give you the actual test and I give you a formula sheet just so if you got this wrong, your whole test won't be wrong. That's how this will work. All right. Or you might get a quiz, and your quiz might be like starting next week. Write the identities. You'll start off with like half of it filled out, and you'll need to like fill in the blanks. Okay. So I say, kind of like the unit circle. This is something that you should know. All right. You know the reciprocals. That's easy. Even odd functions, you could probably figure that out. You can figure this out. Y over x, oh, sine is y, cosine's x. You can figure that out. This one might take a little bit of memorization. But memorizing can be difficult. Understanding is easy. Once you understand it, like you don't forget it. Okay? You guys got any questions? All right, so let's see where we actually use these. All right. Let me zoom out a bit. Okay, so we have these different expressions, and they can be simplified, and we can write them without a function, so without a fraction. So what we'll want to do is use what we know about all these different identities to try to simplify these as much as we can until it meets the criteria. So we normally want to get it into just one term if we can, and we don't want to write it having any fractions when we simplify it. Our identities will help us do this. So I'll be honest, this would probably be like, this is kind of weird, and I don't want to scare you or anything, but it's kind of like proofs just slightly, where when you did proofs in geometry, you started with something, and you had some destination you wanted to get to. How you get there can change. Like maybe you say all triangles are congruent if they're this type of angle, or side, or angle, side, angle, all that stuff for proofs. Now you don't have to do this like a proof. You don't have to explain what you got. You don't have to do all of that. But it's kind of like that in terms of.
In the sink.
Okay, you just put it right here, or just throw it away. Yeah, just throw it away. I appreciate it. But these kind of work the same way. Like, I could do this problem and I get a result doing it one way. You might do it slightly different, but at the end, we should probably get the same thing. All right? So it's kind of like proofs in that sense. As I was telling the first block class, it's kind of like if I said, hey, let's leave here, let's meet at Chick-fil-A. Like, some people might go by the alligator pond. Some people might take the parkway. Some people might go by their house and then go to Chick-fil-A. Like, the route could be different, but we all should end up at Chick-fil-A. That's what's important. Okay, so these are kind of like that. It can have a bunch of different paths to get to the destination, but we want to simplify it, and we want to write it in terms of no fractions. So let's kind of see what we're getting into. So a lot of times with these, I'll always kind of want to refer back to writing it in terms of just sine and cosine. So whenever you get stuck, or whenever you feel like, I don't know where to go from now, maybe try to rewrite it in terms of sine and cosine, and then take a step back and see what you see. Maybe something will cancel. Maybe you can combine something, and then that can help you move forward. So if you look at this first one, just looking at these, none of these will simplify off the bat. These are three different functions. I'm multiplying all of them. Nothing cancels out, nothing simplifies or anything.
Cotangent is cosine of sine.
Yeah, so we're going to start using these identities and rewriting them in terms of sine and cosine. So I hear London thinking we can rewrite cotangent as cosine over sine using the quotient identity. Before we go that far, how can I rewrite secant?
1 plus tangent squared.
I could,
Secant squared.
which wouldn't be a bad path.
1 over cosine.
Yeah, and I can square it.
Easier.
Yeah, I can square it. So we're going to go for secant. We're going to rewrite it as, where's it at? Right here? We're going to write it as 1 over cosine squared. All right? So we're going to write all this in terms of sine and cosine, and then let's see what we got. So secant, we said, is cosine's reciprocal. So I'll rewrite secant as 1 over cosine squared of some angle x. And then we said cotangent can be written as cosine over sine. So let's do that. Cosine x over sine x. Everybody okay? And then cosine, let's just leave that as cosine for now. Let's see what happens. So the nice thing about writing it in terms of sine and cosine is I think some things will cancel out and combine. So sine doesn't cancel out with anything but cosine. So one cosine times another cosine is what?
1. 1.
What if it was,
Squared?
yeah, what if it was x times x? X squared, right?
Oh, x squared.
So this will be cosine squared.
Oh.
Okay, now I could cancel them out like 1 divided by 1 and then 1 more divided by 1 more. Let me put them together so we can see what's going on. That didn't change, but here I'll do cosine times cosine gives me cosine squared divided by sine. Can I cancel out the cosines?
Yes.
That leaves me with what?
Leaves you with 1 and sin.
1 sin. And can I write this in terms of a fraction?
Yeah.
No,
No,
it's
not
a
a
no
fraction.
fraction.
So-
So it would be cosecant.
Cosecant. So I'll use the reciprocal. Whenever I have 1 over sine or sin, I can rewrite it as cosecant of whatever the angle is. So my final answer is
Cosecant delta.
cosecant x.
Oh, x.
What'd you say, delta?
Yeah, that was the weird circle thing.
You could do that. It wouldn't be wrong. Since we had x here, we'll just keep using x. And that weird symbol is theta.
Oh, well, it's delta now.
Delta's the
I don't think the mathematicians are gonna go for that. So,
Well, it's okay because I'm not.
are the people in who speak Greek? You can't just change their language. I think Greek,
Greek people do.
and I think nah, let me not get into that. I don't know.
Yeah.
I think our language. Where does our language come from? Latin?
My brain just poof.
It's Latin, Greek, or
I feel like it probably does.
American.
American? We speak American.
We speak
We spent our
American.
Sunday in school.
Oh, I forgot that wasn't actually a language.
Yeah.
That's true.
I know what you mean.
English.
Bring that back.
Yeah. So people say, what do they speak in England? English. What do they speak in France? French. What do they speak in American? America.
American.
American. And everybody. That used to be a thing. All right. All right. Let's go to the number. Example number 2. Looks similar. Let's maybe try to write it in terms of sine and cosine. How can I rewrite tangent as? What goes on top?
1 over cotangent.
Sine over
I can.
cosine.
Oh,
Sine over
God.
cosine. Yeah. I could rewrite it. You're not wrong, Vivi. But
Oh, no.
that doesn't, that might not make my path shorter. And honestly, I'm working these and I kind of know where we should go. But in reality, as you do these on your own, you might start doing something and you might say, this isn't taking me anywhere. Let me restart. And then I'll restart. But I know since I'm working this, I kind of know where we should go. I'm kind of cheating. But in reality, you'll probably start and say, this isn't taking me nowhere. Let me restart. So quoting identity says I can rewrite tangent as sine over cosine. I think we leave cosine squared as cosine squared for now. And then I can rewrite secant as what?
1 over cosine.
1 over its reciprocal, cosine. And I'm sorry I keep changing up on it. It should be x. Or maybe I'll do block. Sine block divided by cosine block. All right. Anything cancel?
No. I mean, I guess you could take 1 cosine and then the other cosine, then cancels the cosine together.
Yeah, so I can cancel I can make it to just cosine here by canceling out with cosine. And then I got another one.
Yeah, then
And
you can cancel that out with the other one.
So I can cancel those two out completely. Think about this. If this was like, and don't write this, but if this was x squared, one over x, like I put them together, it would be x squared. This would all cancel out to be 1. So it's the same with these functions here.
That would be sine x.
Yep, sine times 1 is sine x. Is it a fraction?
Nope.
No.
I got it simplified as I can. This is my expression.
So one.
All right,
I
questions?
actually had that in my head too.
So it was,
No.
the first part was
It
sine
looks
x
good.
over cos x, or,
That song is actually
Over here?
good for me to help people get
yeah, right there.
compounds.
Yeah.
okay,
We changed tangent to be sine over cosine.
okay.
And then in the last part, we changed secant.
So leave you alone.
Yeah, and it should be x's. I wrote theta, but scribbled it out. All right, any questions? Okay, let's go to 3. So I see some sine and cosine. I probably maybe want to change this tangent at some point. But if you think about it, like I have a fraction and then I have like a term that's not a fraction. I want to get these together so that I can maybe add them at some point. So just to kind of give you reference, like imagine if this was like maybe 2 over x plus 1 plus 3. I can't add these together. In order to add these together, I need a common what?
Denominator.
Common denominator. So to get a common denominator, I would take this bottom and multiply the top and the bottom of this side by it. And technically, I would take this bottom and multiply this side by it so they would get the same denominators. But since it's just over 1, in this case, I wouldn't do anything here. But I say that to say, when we go over to this one, I need tangent to have this same denominator as this term on the right has.
Okay.
Right, so what do we say? Do we want to go ahead and just change it to maybe sine over cosine to get us started?
Yeah.
Let's do that to get us started. So
Is it 1?
the answer?
No.
Did you get one?
No, it
I
would.
haven't written anything down yet. I'm
Wouldn't
just
it be
Okay.
2? Would it be 2? Because it's like sine over sine. No, that would cancel. I don't get
Not
this.
2.
Did I hear Twitter?
So I'm just rewriting the first term. The second one we said we could change to sine theta over cosine theta.
So those would cancel out.
What a cancel?
The cost, the term.
Are we multiplying them or adding them?
Oh, okay.
Yeah, so they don't cancel like last time. I like how you're looking for what's canceling them. Okay, so at this point, I want to put these two together. I can't just yet because I need a common denominator. So basically, the common denominator will be 1 plus sine times cosine. So if I come to this one, in order for my common denominator to be 1 plus sine times cosine, I need to multiply this side by cosine.
Okay.
And the other side by 1 plus sine.
Yeah, that way they get the same bottoms. Okay? So what I'm saying is, this first side, I'm going to multiply by this denominator. So cosine theta, whatever I do to the top, I got to do to the bottom, so I don't change the value. I'm going to multiply that to what was already there. Cosine theta, 1 plus sine theta.
Oh, dear.
Okay? All right, and now this right side needs 1 plus sine theta as a common denominator with cosine. It's already got cosine. This one didn't have cosine, so that's why we multiplied it there. This side needs this denominator. So I'll take my sine over cosine. And I'll multiply that by 1 plus sine theta, 1 plus sine theta. So now it looks crazy. I'm going to put them together and it won't look as crazy. So now the denominators are the same. This is multiplied together, this is multiplied together, it's the same thing. So now our denominator is cosine theta times 1 plus sine theta.
Wait, what?
Theoretically.
Wait, I'm confused.
So this denominator, when I multiply them together, I get cosine theta times this parentheses, right?
Oh, yeah.
That's what this is. Over on the right side, it's the same thing. Cosine times this. Kind of like if I had 2 over x plus 1 minus, I don't know, 3 over x plus 1. I can write this as 2 minus 3 all over x plus 1 because the denominators are the same. That's what we're about to do. Or maybe if I use numbers, 1/2 plus, since the denominator is the same, I can just make it one fraction.
Okay,
Does that kind of make sense?
yeah.
So that's what we're doing here. I'll make it one fraction. On the top, cosine times cosine. Cosine squared.
Cosine squared.
Plus sine times 1
Is 1.
sine times sine.
That's a long fraction.
Sine squared.
No.
I know it looks crazy. We're going to simplify some stuff. It's going to not look as crazy. All right. Now, if I look at the top, right here, I have cosine squared plus sine squared. I think that's an identity. Whenever I add them two together, what does it come out to equal?
It comes out to equal 1.
1. That's from my Pythagorean identities. So it's not in the same order, but sine squared plus cosine squared equals 1. So these two things I have in brackets will come out to equal 1. What I really should do is rearrange it, put this sign in front so you can see it, but
Yeah.
So
So
I'm going to just go ahead and just write that as 1.
So we go back to 1 plus sine.
Yeah, but I got everything together though.
Oh my god. No, I'm crying.
So let me do this so you can see what we changed.
I mean, it's I think I understand it. I don't know. I don't know if I do. I could try it.
I think I do.
Is it simple by cosines?
Okay?
Oh my gosh.
Why are you, oh my gosh?
Because
You
it's
just-
just so much easier than
you just-
we thought it'd be.
You're just trying to, you say, oh my gosh, because you see what it's going to be?
Yeah, 'cause I
Okay.
can see where now I can see, but everything else was just so. Oh my god.
Okay. Everybody okay here?
There has to be a shortcut. There's no way.
Are there any questions how we got here? Because everything's about to go away. It's about to cancel out. I'm not going to say vanish because you shouldn't do that in math, but it's about to cancel out.
If the cosine is the denominator, and if we cancel those out, it would just be 1 over cosine, right?
Yes, ma'am.
That means it would be the other way, secant. It would be secant then.
Okay. So what cancels out now?
1 plus sine.
1 plus sine. I have 1 plus sine on the top. I also have it on the bottom being multiplied. So those two things will cancel out to be 1. So what I'm left with on top is 1 divided by, what's left on the bottom?
Cosine.
Cosine. Can I leave it as a fraction?
No, no.
So I got to use the reciprocal. What's cosine's reciprocal?
Secant.
Secant. So this comes out to equal just secant theta.
Okay, let's keep going.
So no questions on this one?
No.
Alrighty, let's go to number 4. Alright, so challenge with this one is I see I have something squared here and then the bottom is not squared. My first thought might be, can I use Pythagorean's identity to rewrite tangent of something? But when I go and look at tangent, I see it's 1 plus tangent, or it would be tangent plus 1. So I can't really transform it into secant squared because it's minus 1. So I can't do that.
Can we combine sin into sin squared?
No,
it's
because it's
plus.
adding.
Multiplying and then adding.
It's adding, yeah. So I can't do that. What I think I would try to do is get rid of this squared and just get it to be just tangent. So in order to do that, what we need to have understood from Algebra 1, Algebra 2, and what we did earlier was So think about if I started off with, let me do this, x minus 2, x plus 2. I tell you this is x squared minus 4. I didn't write any middle terms. Why didn't I write any middle terms?
What do you mean?
Because there are no middle terms, they can't.
Because they cancel. If I were to fold this, first times first, x squared, outer times outer, 2 times x, inner times inner, negative 2 times negative x, and then last times last, negative 4, these middle terms cancel out. So what I'm left with is just this x minus 4. So if I went backwards to get what I started with, I would say, first times first, I need x and x, right? And then what number squared gives me 4? 2. Now, to get the middle terms to cancel out, I just need the signs to be different.
-5.
So 1 positive, 1 negative. If I started off with this, this is what I would end up with. Does that kind of make sense?
So we're
Yeah.
unfoiling that tangent.
Yeah, we're going to just split it up. So I said all that to say,
We're unfoiling.
yeah, we're factoring it out.
Oh yeah.
We're factoring it.
I hate factoring.
Okay, so I said all that to say, to split this tangent up, I'll have tangent t something 1, tangent t something 1.
Oh, it'll be.
If this is plus 1, this one should be minus 1. If I tried to fold it back, I get tangent squared. Last times last would give me negative 1.
My handwriting's good today.
And maybe now, if we factor out sine of t, you can kind of see how things are about to go, but let's keep going. So let me write what we still got to start off with as well. Actually, while we're here, let's do something to the bottom. Everybody okay with the top? Okay, so on the bottom, do both terms, tangent t times sine t plus sine t, they both have a sine t, right?
Yeah.
So I can factor that out. I'm going to take out sine t from the first term and the second term. So what that'll give me is sine of t, parentheses, what stayed in the first term?
The t? Oh, tangent.
Tangent plus, what's my placeholder here?
1.
Yeah, 1. Good job. 1.
The t is freaking me out because I just think, I don't know.
Yeah, it is. I agree.
Yeah, the way it looks is weird.
I agree. All right, so we just factored out sine of angle t. If I distributed it, I could get back what I started. Everybody okay? So now I'm sorry.
Can you show me that in like X form?
Yeah. So if we did that, you might get like, let's say if it was like, maybe 2x squared plus x. And then you factored out one of the x's, you get x times 2x plus 1.
Can you lower down your stick?
Yes, I can. I'm sorry. So if you started off with 2x squared plus x and you factored out one of the x's, this is what you get.
Okay, yeah, I think I get it.
All right. So now, are one of the parentheses on the top the exact same as one of the ones on the bottom?
Yes.
What is it? Tangent t plus 1? So those cancel. Everybody okay with those canceling? Okay, so on the top I got
Sin t plus 1 over sine t.
Minus 1 over sine t.
over sine of angle t. Huh.
Oh.
Any ideas?
We can
Drop it here.
give up.
Well, we got a fraction, so can't drop it here.
Do you change it to 1 over cosecant?
For sine? That's not a terrible idea. And then I can go and multiply that. You could definitely do that. You'll have some more steps, and you might do that at this
I'll
point.
give you the shortest way.
I'll give you the shortest way just because I know the shortest way, but that would absolutely work. That would absolutely work. Okay? I'm going to change tangent into sine and cosine. Because like I say, whenever you get stuck, that's probably what you want to try to do. Have I gotten all these terms, and can I write any of these terms in terms of sine or cosine? That's the question I would ask myself. And then I would think about the quotient identity, and then I would say, oh yeah, I can write tangent as what?
Sine and cosine.
Sine over cosine. So let me do that.
Sine over cosine
Oh,
minus
that's so weird. So weird.
So sine t divided by cosine t minus 1, all divided by
Sine t.
sine of t.
Boom, boom.
So now, if you were comfortable with your math, you might be able to like simplify at this point, but I'm going to keep change. I'm going to keep change and flip, so to speak.
Would we cancel out the sine?
Eventually, that's going to happen.
Okay.
So
How do we get
I'm going to keep what I got on top, sine t over cosine t minus 1, and that's stuck together for now. What I'll multiply is by the reciprocal. So I'm dividing by sine of t. I'm going to multiply by 1 over sine of t, which is the same as dividing by it. Okay, if it helps, I kept the first thing, I changed the multiplication, and I flipped it from sine of t to 1 over sine of t. But to divide by something is the same as multiplying it by 1 over whatever you had. Everybody okay here? A little bit? Okay. We're about to start canceling stuff. It's going to be simple. It's going to be simplified. I ain't going to say simple, but. All right. So at this point, I would distribute this 1 over sine t to both terms.
distribute? Okay.
Okay? So sine t over cosine t times 1 over sine t. What I'll end up with is sine t divided by sine t,
Which is just cancel.
which will just cancel.
So it's 1 over cosine.
So it'll be 1 over cosine of t.
And then 1.
Okay, so before we go too far, I distribute 1 over sine t and the signs canceled to leave me with just 1 over cosine t. Is everybody okay getting there?
Yep.
Yeah.
And then negative 1 times this will just make this negative, right?
Yeah. It would.
So it'll be minus 1 over sine t. Oh, I'm getting close. I'm getting close. I just can't leave the fractions. What's cosine's reciprocal?
Cosine's reciprocal is
Secant.
secant.
Minus sine's reciprocal, which is
Cosecant.
cosecant.
Are we done?
We are done.
Yeah.
I'm gonna write down here because it looks kind of not good.
Just turn it on.
On this back side, it's basically the same process, but in my opinion, a little bit easier because we at least have some end goal that we're trying to get to. So in these next ones, we call these verifying these identities. So basically, we start kind of how we started the last time, but kind of like a geometry proof, you have to show how this comes out to equal what's on the other side. So for instance, how in the world does this become negative 1? That's what we need to show. Or we go over to this one. How can the left side come out to equal the right side? We'll do just what we did to show how that happens, and that's verifying. It's not like a proof, though. You don't have to write, oh, this is because the reciprocal identity, or this is because of this. You don't have to write that. You just do what we just did to show how you get from this to this. More times than not, you will work the left side and want it to look like the right side. But from time to time, you might say, you know what? I feel more comfortable about working the right side and getting it to look like the left side. So you might choose to start on the right side. Normally, I'll start on the left. Most of these will be easier to start on the left. It'll be set up for you to start on the left. But you can start on either side. You might even simplify both sides sometimes to get like a more simplified answer. So like I say, there's a lot of paths to get to where you want to be. But we should all end up with like the same thing once we get towards the end. Okay? So, these problems can have like a little bit more pieces to it. So I got some steps for you to like if you get stuck when you start doing these on your own. All right, so you'll work with one side of the equation. So most of the time it'll be the left side. Not always, but most of the time you'll work from the left side and you'll want it to look like the right side. You'll use the identity step 2 like we've been doing. Step 3, sometimes you'll do like algebra where you factor out something or you multiply the denominators by something. You might do some algebra to get it simplified. And then step 4, which is probably the one that you'll get to, if you get stuck, try to write it in terms of sine and cosine and then see where that takes you. A lot of times that just helps out for whatever reason. Okay, so let's do number 5. All right, so I don't like cosine of this negative angle, tangent of this negative angle. This looks like even and odd identities, right? So whenever I have cosine of a negative angle, I can just write it as
Positive cosine.
positive cosine. What was my other function? Tangent? Tangent of a negative angle, I'll just write it as negative tangent. That's what these things let me do. Because since I don't know this angle, there's really not much I can do. But since I can rewrite it, it helps me out a little bit. So we're going to write this as just cosine x times negative tangent of just x. And you don't have to put it in parentheses. I'll put it in parentheses so it doesn't look like a blur.
So this is multiplication.
This is multiplication,
Yeah.
not subtraction. And you don't have to write it equals 1. If you want to, you can run your negative 1 all the way down, but you don't have to write that. At the end, we'll say negative 1 equals negative 1. This is me showing you how we got there. All right. So,
What do we do?
you tell me. I see some sine and cosines.
Do we?
Maybe I'll change tangent.
Yeah.
Okay, what can I change tangent to? What goes on top, sine or cosine?
Cosine and sine. Wait, if it's negative. Sine.
If it's negative, this outcome would just be negative.
Oh, okay,
But-
sine.
I can rewrite it as sine over cosine.
Okay.
So I'm not going to change cosine. I will change this to negative sine of x divided by cosine of x, all divided by sine of x.
So the cosines
Yep,
cancel, right?
yes they do.
And then you would be left with negative sine over sine,
Yep, which is,
which is negative 1.
so there we go. So what she said was, this is multiplication. Cosine x times this fraction, the cosines will end up canceling. So what I'll be left with is negative sine of x divided by sine of x. These two things cancel out. Negative 1.
Holy fart.
These things cancel out to equal negative 1. So negative 1 does equal negative 1. We just verified that this is true. So this would be like the left side came out to equal this, and then the right side was negative 1. So you don't have to write it like that. You just do your steps, but this is me verifying it. Okay.
This is our last example.
This is our last example. Yep.
Yay, we're
I
done.
got a minus 2, by the way.
Okay. It wasn't that bad, was it? All right. I'll work on it. All right, guys, got any questions?
No.
Okay. So these other examples we'll do next class, and we'll have some time to work on stuff. Hopefully get some time where some of you guys will ask me for help and get some help with questions and stuff. We'll pick up here where we left off. So don't look at me crazy when I start saying, where did we leave off last class? I don't remember.